Engine Performance 1, Test 12. Which component listed coordinates engine and transmission operation, processes data, maintains communications, and makes the control decisions needed to keep the vehicle operating?
PCM.
Powertrain control module. Excuse my hiccups, by the way, because I picked up some hiccups when I was drinking cold tea at docks. Which term below describes the electrical potential used to communicate?
Voltage.
Voltage is always going to be your electrical potential. Which computer function is defined as a voltage signal from a sensor or switch?
Input.
You know, an input, like on your regular PC, what's an input?
Input is when you print something.
Keyboard, mouse.
I'm saying output.
Yeah, no. Keyboard's input. Mouse is input. Output's your monitor. Output's your, whatever. See what I'm saying? Think inputs and outputs is for computers and all that.
So that one.
That's going to be input. If it's a voltage signal from a sensor or switch. If it's from a sensor or switch, it's an input. When you mash the brake, the PCM knows about it. When you do anything else, there's a switch hooked to the PCM. Like on your, the little overdrive cancel, like on your stalk, you'll have an overdrive cancel button, particularly on your Fords. When you push that button, that light instantly comes on, and you're thinking, I just pushed this button and turned on that light. Well, you didn't really do that. What you did is you pushed the button and it fed power to a particular pin on the PCM. The PCM fed a signal back up the stalk and turned on the light. So, that basically is a long loop that comes with it. It looks instantaneous the way it works. Although it's an input and an output. That's why I use that for an example, because the light's an output, the switch is an input. You didn't turn on the light, the computer did, based on the input. Okay. Which computer function describes how the computer handles inputs? Process ain't complicated, is it? What term describes the task of cleaning and amplifying input voltage so it can be understood by the computer? Is it pulse width modulation? Read-only memory? How about input conditioning? I learned about that in '81 in Houston at GM school. What happens is the computer doesn't like analog signals. It's more of a digital creature. So if you get, what's the difference between an analog signal and a digital signal? You guys remember?
One of them is just on
or off. That's digital. That's right. That's like that light switch over there. It's digital. But analog is like when you put the knob on the wall where you can dial the lights up and dial them down to make them forgive you your mood lighting or whatever. You don't want lights to be as bright. Like if you got a hangover or something, you don't like the bright lights, you turn off. All right. So anyway, let me see. So anyway, that's input conditioning. So what it has to do is, this is what the computer does. It has a threshold, right? And it's got a threshold setting. And when this analog signal breaks over that threshold, it actually translates that to an on. And it keeps it on until it breaks over, going back the other way, and then it translates it to an off. See what I'm saying? So it actually conditions those inputs so it'll be digital. You know what quanta is? You ever heard of that? You know what quantum mechanics is? This is an analog motion, right, with my arm. But what quantum mechanics dictates is this is a bunch of little small digital motions that are so tightly resolved that they look like and everything that you see, everything that you see in nature that you think is analog is actually digital on a tiny scale. That's what quantum mechanics is all about.
That's how a Rolex, though, you think it's just moving real smooth, it's constant, but it's actually a bunch of really small ticks that you can't even tell.
It is, and a Rolex, though, is self-wind. It's not quartz, But the more a quartz watch clicks like 22,000 times a second, tick, real fast, and a Rolex watch or one of these self-wind ones usually about 60 times a second or something like that. If there's a guy that I went with a watch repair place, and he would actually hook the watch up and it would pick up these ticks, and he would actually adjust the watch until those ticks were really within a close line. And he said a self-wind watch, you could put them in a band about that wide, but on a digital watch you could make them almost draw a straight line because of this resolution that a quartz watch is supposed to be. I don't know how much importance that had. What you gonna do with that information? Let's see, which computer function describes keeping information in electronic memory? Storage. What is non-volatile memory? Can anybody tell me?
Memory that will remain.
Yeah, when you turn off, when you disconnect the battery and you take the instrument cluster out, you still got those same miles stored, and you can't even erase it unless you actually go in there with something that's programmed to do that. All right. The following statements are correct except. What's ROM stand for?
Read-only memory.
There you go. Read-only memory cannot be changed by a process called reflashing. So that first answer is not right. Read-only memory contains information that changes frequently. Actually, I take that back. ROM can be changed by reflashing, but they call it EEPROM. You know, the EEPROM is the one that can do that. Electronically erasable program, read-only memory. I don't really like ROM in this particular question, personally. Actually, the right answer is B, which means it contains information that changes frequently. Pretty much stays the same most of the time. ROM retains information even if there's no power. ROM stores stuff, makes it non-volatile. It also stores instructions for the computer, and it's considered more or less permanent memory. But your EEPROM unit has to have an EEPROM in it, and what the programmer does is it juices up that pin with 18 volts at EEPROM, and when it does that, it cleans everything out that's in there, and then it writes the new program in. And the program's not really all that huge as far as algorithms go on that particular deal. Anyway, Technician A says information stored in vehicle RAM is lost when the power is turned off. Technician B says information stored in non-volatile RAM is lost when the power is turned off. Technician A, non-volatile RAM holds it. What I was just talking about a minute ago. The RAM in your computer is there for what reason?
So if it shuts down and if it just crashes or shuts down or something, it'll bring back everything like it was when it went off. Like if your RAM.
Well, your RAM, you mean? You mean the memory that you plug into the board?
Like if you've got a document up and it continually saves.
You're not on a Word document.
Yeah.
That's actually saved on the hard drive. That's not saved in the RAM. The RAM is where the operating system is loaded. When you boot up your computer, the operating system is stored on the hard drive, and it loads it into the RAM, and you're actually operating the operating system off the RAM. The RAM is like your workbench. Like imagine that being your workbench over there. Imagine yourself with a little bitty workbench, just like you ain't got much RAM. And every time you get your tools out and you lay them all over the bench, you run out of room really fast. You get me? All right, you put a big bunch of RAM in there. You got a huge workbench. You got a lot of room to work. Works smoother, loads faster, does all kinds. It doesn't have to utilize part of the hard drive to store stuff. Because if it does that, it takes it longer to write, spinning those disks and all that hogwash. That's why solid state hard drives are so much faster. The newer ones are coming out with are good. But anyway, that's what RAM is all about. And then in these computers, you can't change the amount of RAM in a vehicle computer, but they actually have more RAM in them now, obviously, than they used to. But anyway, hold on here. What question are we on?
9 output.
Which computer process describes sending voltage commands to other modules or actuators? That's an output. Nothing even complicated about that. Which component listed allows the computer to use a small amount of electrical current to control a high current circuit? We've talked about this a zillion times.
Relay.
Relay, that's right. You're going to operate that relay. This one boy has got this Mustang. All right, now you guys are boombox radio buffs, right? Where you put the big bumping, thumping boombox in your trunk and all that? Okay, so he's actually got his big power wire run back there, the big red one that's so pretty, that's got the big fancy fuse in it and all that. He's going to hook it right to the battery. And I says, look, you got a post over here in the PDC that's made for that. I want you to just hook it to that. It looks a lot more professional than hooking it to the battery where all that corrosion is. So he's getting that hooked up. He says, now I need to be able to, he says, how can I get my speaker inputs to this is the factory radio now. He said, how do I hook a speaker up to my boombox? Up to my sound system. Now, what would you tell him about that? The aftermarket radio's got little RCA jacks. But he's got a Ford radio in there. I said, well, it's an 11 model. I said, why don't you look and see if there's a hookup for that? I don't know if there is or not. I hadn't looked it up. But I mean, I don't know if I'd scotch lock into my speaker wires because you want good clean sound. But I think it's a subwoofer is all it is, really. All right. But anyway, I told him, I said, if you're gonna have to power that thing up, you know, with another circuit besides the big one back there, then you're gonna need to use a relay for that. But I don't think I understood exactly what he was asking for. Excuse me. Which method of digital switching lets the computer vary the length of time the signal stays on? PCM, FM, PWM, or AM?
PWM.
Pulse width modulation. That's what it does with your injectors. And there's also pulse width modulation communication. Your networks, you know, some of them use pulse width modulation. Like if you plug in a generic scan tool, it's pretty cool when you do that. Plug in a generic scan tool, and if it is one of those that tells you that, like this little one that I carry in my glove box, that's a silly little thing, and I need to show you all that. You may want to buy you one of those to carry around with you. So this little scan tool ain't no bigger than the palm of your hand, and it'll talk to just about any kind of car, and it gives you all kinds of PID information. And it's cool as all get out. I got one. But that particular one, when you plug it in, it goes through all these protocols. There's various different ones, and one of them is PWM, pulse width modulation. That's how it talks. All right, the rate of on time relative to the period of the complete cycle is what?
Frequency.
Duty cycle. Duty cycle. If it was on all the time, that would be 100%, wouldn't it? If it was off all the time, that'd be 0%. But there is, see this? There is a range in here. It's, you know, predetermined. And if this thing is on 80% of the time, and it's off 20% of the time, that's an 80% duty cycle. In your next frame, if it's on, excuse me, 20% of the time, it's off 80% of the time, and that's 20% duty cycle. But it's being going up and down, you see. In other words, if you do this the right way, this would be your signal, like that, and the next time it would be like that. And it was on half the time, next time it's 50%. You see what I mean? That's how they work. I've got a little graphic that I can show on that. Which data set contains only 2 digits? Binary. That ain't too hard, is it? Which circuit in the computer changes continuously variable information to binary information? What did I just tell you guys about?
See.
Analog to digital converter. I was really, that's a conditioner there. Which component could be considered the heart of the computer?
Central processing.
The CPU, yeah, the central processing unit. All right.